The year is 2092. Global civilization has all but crumbled. The only thing left besides the wastelands are the megacities. And here, people fight over the scraps in the streets. That's why I designed this, Blastwave Mark III, personal combat robot. Designed to be harder, better, faster, and stronger than the previous iterations. I'm Caden here from Kepler Electronics, and let me show you how I did it.
Okay, so if you aren't well versed in the combat robotics scene, let me give you some background. Robots have to disable an opposing robot within 3 minutes, with the whole match taking place in a protective box. Robots are split into different weight classes, such as ant weight, which is 1 pound, and featherweight, which is 30 pounds. All 3 iterations of Blastwave up to this point have been designed to compete in the ant weight class. So let's take a look at the first iteration of Blastwave. You can see we have 4 wheels and a drum spinner with screws as impacting teeth, and that's about all we had. The motor mount was terrible, the axle retention was horrible, the bearings were non-existent, the lid was trash, and the drive motors were about as durable as a dandelion. But they weighed about as much too, which is why I chose them. This version had 2 fights, losing one due to the lid falling off and another in a judge's decision after I didn't relock the weapon axle properly. Blastwave 2 is much smaller and used this U-shaped chassis design with separate lids instead of having one lid and the other side printed in with the chassis. We kept with the same weapon motor, but this time mounted it with these metal spacers, which were made by Brian from Team Buttspots. The weapon axle was replaced with a screw which ran through these bearings. However, due to the small size of the chassis, wiring was a nightmare, as I'm sure you can tell. Blastwave 2 had 3 fights, even winning one by outlasting my opponent, but I was still disappointed in its performance. Mobility was not great. I used the same drive motors as the first iteration, which I've already said were not great. I also ran out of spare drive motors, which meant that I had to go into my third fight down a wheel, which nerfed my mobility right off the bat. Most of my spare chassis also warped in transit due to the summer heat, which led to Blastwave nearly failing the safety checks because the weapon couldn't spin up. Blastwave 3 was simple in concept. Fix the drive and fix the weapon. Step 1 to fix the drive was to replace the motors with those used in Stompbot, my other ant-weight robot. These 20mm gear motors lasted a ton of fights in Stompbot, so I wouldn't need to go through them as often. These did weigh a ton more though, which meant that I would only be able to use 2 in order to meet the weight requirements. Since I couldn't go with 4-wheel drive in order to preserve the silhouette of Blastwave, I'd need to use belts to keep all 4 wheels powered. Over to the weapon, it was initially supposed to be a similar construction to V2, with a single bolt through both sides. But I was pointed to shoulder screws by Brian on the MCRA disc hook. Shoulder screws have a lip at the end before the thread starts, which lets me use it as a semi-structural member up front, which means that it won't squeeze the chassis sides into the drum as much. The bearings would also go inside of the drum in order to allow for the shoulder screw shenanigans. He also recommended the use of thrust washers, which lower friction when the drum is rubbing against the sides, helping prevent another drum squeeze scenario. These have little rollers situated radially out from the center, which allow the drum to spin with less friction. Anyways, here's the final CAD. It looks very similar to Blastwave 2, just bigger and with a wider stance. The most obvious difference here is the wheel hubs, so let's start there with the fabrication. Blastwave 2 used the FingerTech hubs, which squeeze these foam tires to allow for easy repairs. I really like these, but I couldn't find a good way to make them work with the requisite pulley system. I tried JB welding these pulleys to the hubs, but they didn't hold up super well. So my only solution was to make my own hubs on the lathe. It's basically the same as gluing the FingerTech hubs to the pulleys, but with a second snap ring groove at the back instead of the flange, which lets me put another washer back there to mimic said flange. To mount the free spinning wheels, I decided to use some screws with Kep's nuts to provide the axle solution, and then a nylon lock nut on the outside to hold it on. I really wish I could have used bearings, but even without them it does seem to spin pretty well. The wheels I got are slightly too large, so they touch in the center. I would normally just increase the spacing in the model and reprint everything, but the belt diameter is just a bit too small and I don't want to overstretch it. Since there aren't wheels available in the necessary size, I decided to take a hole saw and do some cutting. The 2-inch hole saw is designed to make a 2-inch outer diameter, but will leave a slightly under 2-inch diameter remnant. The material that these are made of is the foam tiles that you can get from basically any hardware store, but I actually just cannibalized some older foam wheels that I had made using a similar method for my 150-gram combat robot Thwackintosh. I toss the wheels on, and yeah, that works. As for the drum, it pops into the front pretty easily. Both needle roller bearings go inside, the shoulder screw goes through, don't forget to put on the thrust washers and the belt, then screw it into the nested nut on the other side. It spins pretty well without the belt on the pulley. The motor mounts the same way as the previous iteration, with the screws going through the spacer, though we have to time travel a little bit to get it on, as the wheels need to be taken off first. After that, it's just installing the electronics and tossing the lids on. Here we have a FingerTech power switch, dual brushed ESC for drive, BlHeli brushless ESC for the weapon, and whatever radio receiver I pulled out of the tub first. Speaking of the ESC, I reconfigured these using the BlHeli suite. Alex Mordue has a great guide on this that I followed, but it boils down to installing some stuff, flashing an Arduino, then adjusting the levels as you see fit. Here's me trying to spin it up without reconfiguring, and here's with it. I don't even need to oil the belt like the last 2 iterations. With all that done, it was time to weigh everything. And it's overweight. I tried swapping in some plastic lids, and it's still overweight. So my next move was to pocket the chassis a bit, and I'm happy to say that I am now under the limit. I'm a bit sad that I can't use the metal lids, but at least I can compete in this scenario. I was also planning on using some of this chonky bar stock to make a heavier weapon, but I guess that won't be happening anymore. All in all, that's Blastwave 3. I fixed the drive issues that plagued the first 2 iterations, hopefully without causing any new ones, and powered the weapon up so I won't have to worry about it anymore. The only thing remaining is to pack the chassis in a cooler so they don't warp when driving to the next event. If all goes well, I should be taking it to an event or 2 very soon, so subscribe if you want to see that. Anyways, thanks for watching, goodbye.